Hey everyone, I'm going to try to give you some help with what happens when you scale a diagram in one dimension. Here I have a wonderful picture of a cylinder and the formula that I got off the top of the document, pi times r squared times h. If I scale in one dimension using a scale factor of, let's say, 3, that means I might want to make one of the dimensions of this cylinder 3 times larger. So I choose the height. The new height is going to be 3 times as big as the original. This little s stands for scale factor, or scaled. The new volume is going to be, well, pi hasn't changed. It's still pi. The radius hasn't changed. It's still r squared. But the height is now changed to 3 h's instead of a single h. If I rearrange these the way that we usually do in math, which is to take coefficients and move those to the beginning, then I can just rearrange this so that the volume is 3 times pi times the r squared times the h. You can see that I've just used the commutative property to rearrange these values. Look at the original volume compared to the scaled volume. You can see that the scaled volume is 3 times as large. If I scale a single dimension, then the new volume will be that scale factor times larger. This is true even if I use a small scale factor. Let's say I use a scale factor of 1/2. The height now becomes half as tall as it used to be. Instead of 3 h's, I now have half an h. And my scaled volume will be 1/2 of the original size. This is true even if I start putting in values. The directions may say, hey, use 3.14 for pi. If I take half of 3.14, I'm going to get 1.57. This is exactly 1/2 of the original value. Whoops, I should take out the pi at this point. 1/2 times 3.14 is 1.57. And then we have r squared h. The original volume, if I'm replacing pi, would have been 3.14. Maybe they'll tell me the radius is 4. That's not going to change my answers. I simply do some replacement, do some calculating, and you can see that we're still going to get 1/2 of our original size.